Find the slope and y-intercept of each linear equation and then sketch the graph. If your equation is written in the form y equals mx plus b, then m, which will be attached to x, will be the slope of your line. And this constant on the end, b, will be your y-intercept. Remember, to find the y-intercept, you replace x with 0, so your mx term will go to 0, leaving y equals b. So 0b is your y-intercept. Going back over here to the equation, y equals 2x minus 6, y equals mx plus b. That's the right format. Our slope is 2. Our y-intercept is negative 6. So if you go to the point 0, negative 6, and you use your slope to count off directions to another point, if we go up 2 over 1 from the y-intercept, we land at a second location that our line has to pass through. If you want to check it, if x equals 1, 2 times 1 minus 6 is negative 4. So that tells you that this point's correct. Draw a line through those 2 points, and you have your graph. The key is to get your equation, if it's not already written, in the form y equals mx plus b, because then you'll know your slope. That'll be the value of m, and your y-intercept will be the point 0 and whatever constant is in your equation. Our follow-up example, we have the equation y equals 5 minus 3x. This is in slope-intercept form, but our terms are backwards. Our constant is 5, so that's our y-intercept. Our x term is negative 3x, so negative 3 is our slope. Plot your y-intercept first. Count down 3 over 1. That's your second point. You can always check if you let x be 1. 5 minus 3 times 1 is 2. That is definitely the y value. Plot your 2 points and connect with a line. Always plot your y-intercept first, and then use your slope as directions to a second location before you connect. Find the slope and y-intercept of the equation y equals negative x plus 3. X has a coefficient of negative 1. That's the slope of the line. 3 is our constant, so 0, 3 is our y-intercept. Plot 0, 3. Count down 1 over 1 from the y-intercept, down 1 over 1. That takes us to this location. Connect those 2 points with a line, and you have a visual representation of all ordered pairs that satisfies that equation. For example, 3, 0, we notice the line goes through there. If x is 3, negative 3 plus 3 is 0. We plug a 3 in, our answer is 0, so 3, 0 is a point on that line. Y equals 1/4 x plus 2. 1/4 is our slope. 0, 2 is our y-intercept. Plot the point 0, 2, and then from there, if you'll go up 1 over 4, you will find the second point or another point on your line, connect, and you've got the graph of this linear function. 1/4 x plus 2. If you wanted to double check that this second point is right, if x equals 4, 1/4 times 4 is 1, plus 2 is 3, and that's our answer. That's our y coordinate. If your equation is a y-only equation, where it's just y and another number, you're going to always have a horizontal line. Let's investigate. y equals 3 can be written as y equals 0x plus 3. Our y-intercept is at the point 0, 3. Because our slope is 0, there's no vertical change. It's all horizontal. As long as you pick another point that has a y-coordinate of 3, you can plot it and connect with a line. So just remember, y only, horizontal line. A similar comparison is x only. If all you have is x equal to a number, or x and a number in your equation, then you'll have a vertical line. We can't write that as y equals mx plus b because we don't have a y variable to do it with. What we do have is the ability to plot 2 points that have an x coordinate of 4. If we go over to 4 and plot 4, 0, this point satisfies the equation because the x value is 4. As long as we go over 4, it doesn't matter how much we go up or down. As long as the x coordinate is 4, this equation is happy. The slope is undefined for all vertical lines, and there is no y-intercept in this graph. X only, vertical line. And then the hardest type of problem dealing with slope and y-intercept form is if you don't have y isolated, like this equation, 3x plus 5y equals 10, but we can get y isolated. There's 2 steps to it if it's not already isolated. Your first step is to move your x term over across the equals and just be sure to change the sign of it. Positive 3x on the left side will be a negative 3x on the right. This 10 is positive, I'm just scooting it down. That's your first step. Move your x term over, change the sign. Then, if y has a number attached to it, whatever its coefficient is, in this case it's a 5, divide all your terms by 5. 5 divided by 5, that's 1y, equals, if your fraction reduces, great. If it doesn't, don't worry about it. We can leave that as negative 3/5 x. 10 divided by 5 is 2. Our y-intercept is 2. Our slope is negative 3/5. Plot your y-intercept first, and then negative 3/5 would be down 3 over 5. That's another point we can plot. Connect those 2 points with a line, and you have your graph using slope and y-intercept. And then our last example, 2x minus 3y equals 12. Moving the x term across, changing its sign, positive 2x becomes negative 2x. Don't forget the negative with that 3y. Divide all the way through by negative 3. Negative 3 divided by negative 3, that's a positive 1y. 2 negatives in the same fraction give it a positive value overall. And 12 divided by negative 3 is negative 4. 2/3 is our slope. Negative 4 is the y-intercept. The point 0, negative 4 is located here. A positive 2/3 slope, that's up 2 over 3. Plot your second point, connect with a line, and you have the graph.